Hello students, welcome to my channel and good wishes from our channel. In this video, we are going to discuss a Fourier transform. Fourier transform of a function f of x is equal to 1 for modulus of x is less than or equal to a and 0 for modulus of x is greater than a, and also evaluate integral runs from 0 to infinity sin x by x into dx value. Students, in this example, we make use of two results. One is Fourier transform of f of x as well as inverse Fourier transform of f of x. First, I am going to divide the Fourier transform, which is integral runs from minus infinity to infinity. Okay. So, which is f of x into e raised to iux into dx. And first we shall use this, then later we'll go for that. It's a very simple example, student, to try to understand. So we need to use this f of x value inside this range, that is minus infinity to infinity. Treat it as a number line. Okay. There is a 0 in between them. Okay. Right. And first, let us understand what does this modulus of a less than or equal to a represent. The modulus of x less than or equal to a represent x lies between minus a and plus a. So that is minus a is in the left side, plus a is in the right side. Okay. Try to understand the value of 1 exists only in this interval. So we need to consider the value of f of x is equal to 1 in the interval minus infinity to infinity. Otherwise, we can also write it in this form. F of x value is 1 in the interval minus a to a. Okay. So it is 0 other than this. Okay. Very simple to understand. Okay. Now let us observe here. So to use these results here, I need to use one more result, that is the property of definite integral. That is, if integral runs from a to b f of x dx can be written as, if c is the value which is lies between a and b, in such a case we can able to write it as a to c plus integral runs from c to b. This function is as it is. So how to write minus infinity to infinity? To understand this, you can write it as minus infinity to minus a. Okay. Plus next is minus a to a plus a to infinity. Okay, you can write it as, this is f of x into e raised to iux into dx, f of x into e raised to iux into dx, f of x into e raised to iux into dx. Okay. So the value of f of x in the interval minus a to a. Okay. So other than this, it is 0. Other than the interval means minus infinity to a. We'll write here, just to understand. Means minus infinity to minus a interval, it is 0, and from a to infinity is also 0. So therefore, integration of, you can write one more step, minus infinity to minus a, f of x value is 0, e raised to iux into dx plus minus a to a f of x value is 1 e raised to iux into dx plus a to infinity f of x value is 0 e raised to iux into dx. Fine. So first and last integrals are 0. So you can integrate e raised to iux with respect to x. E raised to iux with respect to x is integration of e raised to iux is e raised to iux divided by coefficient of x is iu. So between the limits minus a to a. Fine. Now you can take 1 by iu outside, substitute upper limit in place of x, e raised to iua minus e raised to minus iua. Further, by make use of the result, that is, we know that e raised to I theta is equal to cos theta plus I sin theta. Similarly, e raised to minus I theta is cos theta minus I sin theta. Therefore, you have Fourier transform of f of x is denoted by f of u is equal to, this is 1 by iu into 1 by iu into e raised to iux can be written as cos ux plus I sin ux. Next, minus e raised to minus iu a, sorry, a it is a. Similarly, this is e raised to, sorry, cos ua minus I sin ua. This is 1 by iu into cos ua plus, and this minus get cancelled. This is plus I sin ua minus minus plus. It will become 2 I sin ua. This I and I get cancelled. You will get 2 sin ua divided by u. So this is the Fourier transform of the given function. That is 2 sin au. You can represent it by f of u. So we need to find out the integral value, that is integral runs from minus infinity to infinity sin x by x value. Okay, we are going for inverse Fourier transform by inverse Fourier transform, that is f inverse of f of u can be written as f of x is equal to 1 by 2 pi times of integral runs from minus infinity to infinity f of u into e raised to minus iux into du. Okay, fine. So now let us write just only f of x is equal to 1 by 2 pi integral runs from minus infinity to infinity. F of u value is, you can substitute, is 2 sin au divided by u, okay, into e raised to minus iu x by ux into du. Okay. Students, we need to derive this result. So for that, we need to substitute the value of x. So which value of x is suitable here? Okay. So you people already aware that. Just go back and observe. If I substitute x equal to 0, where x equal to 0 lies? X equal to 0 lies in this interval, not in this interval. So when x equal to 0, the value of f of x should be is equal to 1. Okay. So which value is suitable here? We are going to substitute x equal to 0. So f of 0 is equal to, this is 1 by 2 pi times of minus infinity to infinity, integral runs from minus infinity to infinity, 2 sine au divided by u. So e raised to 0 is 1 into du. So what is the value of f of 0? As you know already, f of 0 value is 1 is equal to 1 by 2 pi. Integral runs from minus infinity to infinity, 2 sine au by u into du. Fine. So 2 into get cancel. So what will get here? Just cross multiply pi. Pi is equal to, which is integral runs from minus infinity to infinity, sine au by u into du. Okay. But actually we need to calculate, just go back and observe, we need to calculate integral runs from 0 to infinity, not minus infinity to infinity. Just wait. Okay, first what I am doing is, here I need to replace. Okay, as you know already, in case of one of the property of definite integral, if I change the variable of integration, then the value of definite integral is not changed. So minus infinity to infinity, I am going to change u to x. This is sine of ax divided by x into dx is equal to pi. Further, I will take a is equal to 1. So what will happen by taking a is equal to 1? Integral runs from minus infinity to infinity. This is sine x by x into dx is equal to pi. Okay. So if they ask this value, this is the value is pi. Further, if you want to find the value for the integral runs from 0 to infinity, just look at further. As you know that sin x and x are odd functions, right? And we know that one of the property of a definite integral, as integral runs from minus a to a, f of x is equal to, which is 2 times of 0 to a, f of x into dx, and its value is 0. First one is for even, second one is for odd. If sin x and x is x are odd functions, means odd function by odd function. What is odd function by odd function? It will become an even function. So therefore, because how do you decide odd and even nature? You know this already. F of minus x equal to f of x means which is even. Okay. F of minus x equal to minus f of x. We call it as a odd. So since sine of minus x equal to minus sine x, and x is already odd function, therefore odd by odd is, because it retain minus sign outside, minus minus plus, so it will become 2 types of 0 to infinity sin x by x into dx is equal to pi. So cross multiply 2, we get 0 to infinity, integral runs from 0 to infinity, which is sin x by x into dx is equal to pi by. So that's it. Thank you so much for watching. Okay. If you have any doubt regarding this example, please mention your comment. Okay. Thank you so much for watching.